Here's the weird part. A horn is not really nature's spear. Most of the time, it's nature's counterpunch. Think about goats, deer, antelope, and cattle. When we see horns, we imagine an animal charging forward like a knight with a lance. But that's only part of the story, and often it's the wrong part. Horns are found mainly on plant-eating animals. That matters, because a heavy horn is a terrible accessory for a fast predator. A lion with huge antelope horns would look impressive for about 3 seconds. Then it would have to chase dinner while carrying a pair of dumbbells on its skull. For a predator, speed, balance, and stealth are everything. For prey, the problem is different. The danger is something sprinting straight at you with teeth out. So, horns work less like a sword, and more like a shield with spikes. They let a herbivore punish a predator that comes in too aggressively. Researchers have looked at horned, hoofed animals across many species. Out of 175 horned species studied, 164 fit this defensive counterattack pattern. So, horns are one answer. Herbivores evolved in the survival arms race. They are not just decorations, and they are not just weapons for starting fights. They're what you grow when the world keeps trying to eat you. That also means every horned anime character is, biologically speaking, giving counterattacker energy. If Frieza had horns in his early forms, maybe he was built for defense too. But jokes aside, nature is running a very serious tournament. Plants feed plant eaters feed meat eaters, and meat eaters sometimes eat each other too. That's the food chain, and it's not sentimental about anyone. At the top of that chain, in practice, sits the strangest predator of all, humans. And here comes the real mystery. Humans are perfectly capable of eating meat. Humans have hunted, butchered, cooked, dried, smoked, and seasoned almost everything imaginable. So, why don't we normally eat predators? Walk through a supermarket and look at the meat case. Chicken, pork, beef, lamb, maybe turkey. These are plant-eating or plant-fed livestock, not lions, wolves, foxes, or eagles. You almost never see lion steaks or wolf ribs next to the ground beef. And that's weird, because ancient hunter-gatherers couldn't always be picky. If a starving group found edible meat, they probably didn't ask for a restaurant menu. They likely ate whatever they could safely get, including carnivores when circumstances forced it. Yet modern humans do not eat meat without distinction. We overwhelmingly choose animals lower down the food chain. So, the question is simple. Why don't humans eat carnivorous animals? The answer comes down to 3 big reasons: safety, taste, and cost. And the deeper you go, the more obvious the pattern becomes. First, safety. At first, that sounds like it means hunting predators is dangerous. And yes, obviously, trying to hunt a lion is a bad afternoon. But that's not the main point here. The safety issue is inside the meat itself. As animals live, they can absorb things that are not great for whoever eats them later. That includes parasites, microbes, heavy metals, and other chemicals from their environment. Some of those substances don't leave the body easily. They build up in tissues over time. Now imagine a small animal carrying a tiny amount of something harmful. A larger animal eats many of those small animals. Now the larger animal has collected all those tiny amounts into one body. Then an even larger predator eats many of those larger animals. The concentration keeps climbing as you move up the food chain. This process is called biomagnification. It means a toxin can become far more concentrated in top predators than in their prey. A simple way to picture it is with mice. If one predator eats 100 mice, it may absorb the residues carried by those 100 mice. If another animal eats 10 of those predators, that's the residue from 1,000 mice. The math gets ugly very quickly. In some animals, harmful substances can become millions of times more concentrated. This is one reason certain seafoods can become poisonous. Pufferfish and oysters don't always begin life as little poison factories. They can become toxic by eating bacteria or organisms that contain toxins. The toxin enters the food web, and then it piles up. Carnivores can also accumulate parasites, partly because they eat raw animal tissue their whole lives. They are not grilling their meals to 165 degrees. So, from a human point of view, a predator is often a biological storage unit. It may store the chemicals, pathogens, and parasites of everything it ate. But there's a fair objection here. Humans eat large fish. Humans also eat whales in some cultures. Big fish eat plankton, and smaller fish by the truckload. So, if biomagnification is the problem, why do people eat tuna but not tiger? The answer is partly about biological distance. Land predators are often mammals, and humans are mammals too. The closer another animal's body is to ours, the easier certain diseases can cross over. Disease that can infect both animals and humans is called a zoonotic disease. Bird flu and rabies are familiar examples. For a virus living in an animal to infect humans, it usually needs the right mutations. If the host animal is built very differently from us, that jump is harder. If the host is similar to us, the jump can require a smaller change. At the extreme, a disease from one human can infect another human without much adjustment. That's one biological reason cannibalism is so dangerous. Eating human flesh exposes you directly to human pathogens already adapted to human bodies. If a society did that regularly, infectious disease would eventually become a major threat. Many zoonotic diseases come from mammals for the same basic reason. Rabies is associated with dogs and other mammals. MERS is associated with camels. Plague is linked to rodents and their fleas. Humans are mammals, so mammal diseases often have a shorter evolutionary bridge to cross. Fish viruses, by comparison, would need a much bigger leap to infect humans. That does not mean fish are risk-free. It just means the risk profile is different. Tuna, for example, can accumulate mercury from the smaller fish it eats. People who eat a lot of tuna can accumulate mercury too. Hair analysis has found that Japanese people, who often eat tuna, can show higher mercury levels than people in some other countries. For most people, occasional tuna is not a crisis, but it explains why balance matters. Eating high on the food chain always comes with baggage. The second reason we avoid carnivore meat is taste. When people say they desperately want meat, they often aren't craving pure protein. What they're really chasing is fat. That's why a very lean slab of red meat can feel strangely unsatisfying, and why a fatty dessert like ice cream can scratch a surprisingly similar itch. Fat is flavor, fuel, and mouthfeel all at once. Carnivores, though, are usually not fat little couch potatoes. They hunt, they sprint, stalk, pounce, fight, and survive by moving hard. That often makes them lean, and lean predator meat is not what most humans find delicious. There's also the texture problem. Muscle works by contracting fibers, almost like tiny springs pulling together. When an animal uses a muscle over and over, those fibers grow thicker and stronger. Thicker fibers tend to make meat tougher and coarser. A lazy, pampered animal can have finer muscle texture. A wild predator is more like an athlete who never takes a rest day. That sounds impressive until you try to chew it. Wild carnivore meat is often described as tough, stringy, and gamey. Nature photographer Tsuyoshi Yamagata reportedly once ate lion meat in Botswana. His verdict was brutal. He said lion was the worst meat he had ever eaten. According to him, it smelled unpleasant and was tough and sinewy. So, yes, you can eat lion. The better question is why you would pay for the privilege. Human preference for fatty meat is not random. Fat was essential for survival through most of human history. People who liked fat were better at seeking it out. People who rejected fat had a much harder time surviving scarcity. In evolutionary terms, picky low-fat eaters were not exactly favored. Fat is incredibly energy-dense. Protein gives about 4 calories per gram. Fat gives about 9 calories per gram. That's more than double the energy in the same weight. Fat also helps your body absorb certain vitamins. Vitamins A, D, E, and K are fat-soluble. That means they need fat to be absorbed properly. If you ate zero fat for long enough, you could develop serious deficiencies. So, fat is not just the thing diet ads warned you about. For most of history, fat was survival in concentrated form. There is an old example often called rabbit starvation. Around 150 BCE, a starving Roman army supposedly found a group of rabbits. That must have felt like rescue had arrived. They ate the rabbits, expecting the meat to save them. But many soldiers still starved while craving meat. The problem was that rabbit meat is extremely lean. It is mostly protein, with very little fat. If you eat only lean rabbit for long enough, you can develop severe malnutrition. Your body wants meat, but what it's really screaming for is fat. So you keep eating meat, yet still feel desperate for more. It's a strange and miserable trap. Meat without the part your body needs most. That is why not all meat is equal. The animal's diet also changes the flavor of its meat. Carnivores eat other animals, including tissues that may contain urea and chemicals from decay. When carnivores break down animal protein, their bodies produce more ammonia as a byproduct. Those compounds can contribute to harsh smells and unpleasant flavors. That familiar gamey or musky odor often comes from chemistry like this. Herbivores work differently. They take plant material, including cellulose and carbohydrates, and transform it into body tissue. Ruminants like cattle do this with complex stomachs and microbes that help process plants. Carnivores build bodies by breaking down animal protein and rebuilding it. That route can leave more strong-smelling byproducts behind. Even within one animal, diet can change the meat dramatically. People who have eaten bear say spring bear can taste better than autumn bear. The explanation is the menu. In spring, bears may eat more berries and plant foods. In autumn, some bears eat more fish. That fish-heavy diet can leave stronger flavors in the meat. So the taste of meat is partly a record of what the animal has been eating. This is why farmers can design flavor by controlling feed. Iberian pigs are a famous example. Some Iberian pigs eat acorns as they grow. Acorns contain oleic acid, a fatty acid also found in olive oil. As the pigs eat acorns, their fat takes on more of that character. In a sense, farmers are using a controlled version of biomagnification for flavor. They feed the animal something desirable, then let the animal turn it into meat. So, could we do that with predators? Could we feed carnivores a carefully designed diet and make delicious predator meat? That brings us to the third reason: production cost. Animals do not turn 100% of their food into edible body mass. Anyone who has eaten a giant bowl of ramen understands this intuitively. You don't eat 2 kilograms of food and gain exactly 2 kilograms forever. A lot is burned, wasted, or used just to keep you alive. A rough rule says only about 10% of feed becomes animal body mass. So 10 kilograms of grass might become 1 kilogram of cow. Now, feed that 1 kilogram of cow to a lion. Only about 100 grams becomes lion. In other words, each step up the food chain throws away most of the usable energy. If humans can eat the cow directly, raising the lion for meat is absurdly inefficient. It's roughly 10 times less efficient than raising the herbivore. Or, from plants to predator meat, only about 1/100th survives as edible predator mass. The economics are ridiculous before taste even enters the room. A zoo lion eats roughly 4 to 5 kilograms of meat per day. Its food cost is said to be just under 10,000 yen per day. That's about 300,000 yen per month. Over a year, that's around 3.6 million yen just for food. Male lions reach adulthood around 4 to 6 years old. Females reach adulthood at about 3 years. Even if young lions eat less, raising one to adulthood costs over 10 million yen in feed alone. And that is before housing, staff, veterinary care, safety systems, and every other expense. An average lion weighs about 150 kilograms. Even a very generous estimate might give you 50 kilograms of edible meat. That puts the feed cost around 20,000 yen per 100 grams. For comparison, even elite Matsusaka beef tenderloin can be around 10,000 yen per 100 grams. So lion meat would cost more than luxury beef before anyone made a profit. And remember, the taste report was not exactly glowing. It's expensive, inefficient, risky, and probably unpleasant. That is not a business model. This connects to domestication. Humans cannot simply choose any animal and turn it into livestock. Historically, animals suited for domestication meet several conditions. First, their food must be easy to obtain. Second, they must grow quickly. Third, they must breed under human care. Fourth, they must be calm enough to manage. Fifth, they must not be too nervous or panic-prone. Sixth, they should live in ranked groups with social order. Carnivores fail many of these tests. The food problem alone is huge. If your livestock needs meat, you first need other livestock to feed it. Many carnivores are also too dangerous or aggressive to manage cheaply. And surprisingly, some are difficult to breed in captivity. Cheetahs are a famous example. Humans have admired cheetahs for their speed for a very long time, but making them practical hunting animals or livestock is extremely hard. One reason is reproduction. In the wild, several male cheetahs may chase one female for days. That intense courtship helps trigger ovulation and mating behavior. A small enclosure cannot easily recreate that wild, exhausting ritual. So, even if an animal looks useful, biology can refuse to cooperate. Group hierarchy condition also matters. Animals with clear social ranks can be managed in groups. Humans can insert themselves as the leader or authority in that structure. Cattle, sheep, goats, and horses all make more sense under that logic. Solitary animals are much worse. Put animals with no group tolerance into one pen, and they may simply fight. So, livestock is not just meat on legs. It is a living system that must feed, grow, reproduce, tolerate humans, and tolerate each other. Predators are usually terrible candidates. Still, are there places where people eat carnivorous animals? Yes, and the examples prove the rule more than they break it. Take dogs. There is an old story about a reception at the British Embassy in Beijing. The British ambassador was a devoted dog lover and brought along his pregnant spaniel. A Chinese official admired the dog, and the ambassador asked if he liked dogs. The official said yes, very much. So the ambassador offered him 1 or 2 puppies as a token of friendship. 4 months later, a basket with 2 puppies arrived at the official's home. Weeks after that, they met again at a state event. The ambassador asked whether the puppies had pleased him. The official reportedly answered that they had been very delicious. Whether that exact story is true is less important than what it reveals. It captures a cultural mismatch around dogs. In some places, dogs are family members and hunting companions. In others, historically, they could also be food. Worldwide, roughly 20 to 30 million dogs are eaten each year, especially in parts of Asia. One Beijing restaurant was said to use about 30 dogs per day. Dog-eating traditions have also existed in Polynesian regions, including Hawaii and New Zealand. The reason is not simply cruelty or taste. In many such places, meat was historically hard to obtain. Edible insects were also limited in some regions. In Western cultures, dogs became companions, partly because humans hunted alongside them. They were partners in finding and catching prey. But in parts of Polynesia, there were not many wild animals for dogs to help hunt. So, dogs did not always occupy the same role. Where resources were scarce, they could become livestock instead of co-workers. Still, even dogs raised for food are often fed vegetables and leftovers. Dogs began as carnivores, but over long domestication they became more omnivorous. And today, of course, many people in those same regions oppose eating dogs. Culture changes when survival pressure changes. But what about a true meat-eating predator that people eat as meat? Australia gives us one clear example: crocodile. Crocodile meat exists because several unusual conditions line up. Australia has vast land and very low population density in many areas. Crocodiles can grow in those landscapes without the same costs as barn-raised mammals. Their skin is also valuable as crocodile leather. That means the animal can produce both meat and a luxury material. The economics look less terrible when one animal pays twice. Crocodiles also are not mammals. They are reptiles. And that changes the meat. Mammalian carnivores are warm-blooded, meaning they maintain a high internal temperature. That high metabolism sends lots of blood through active muscles. That can contribute to the strong flavors people dislike in predator meat. Crocodiles are cold-blooded, or, more accurately, their body temperature depends on the environment. They do not run the same constant metabolic furnace as lions or wolves, so their meat does not carry exactly the same mammalian predator problem. It can still have some smell because they eat meat, but people who have tried crocodile often compare it to chicken. That comparison makes sense. Crocodiles spend a lot of time still. Their muscles are not developed like those of constantly moving mammal predators. Because they are cold-blooded, they also tend to produce leaner, lighter meat. So, crocodile works only because many rare advantages overlap. It grows in a suitable environment, has valuable skin, isn't a mammal, and tastes acceptable. That is very different from building a lion ranch behind a grocery store. So, let's put the pieces together. Humans don't usually eat carnivorous animals for 3 connected reasons. First, predators sit high on the food chain and can accumulate toxins, parasites, and disease risks. Second, their meat is often lean, tough, strong-smelling, and not especially tasty. Third, raising them is wildly inefficient because you must feed meat to make less meat. On top of that, most predators are bad candidates for domestication. They are costly to feed, hard to handle, and sometimes difficult to breed under human control. There are exceptions, like dogs in certain historical food cultures and crocodiles in Australia, But those exceptions depend on special circumstances. The ordinary human meat menu is not random. It is a record of biology, economics, taste, danger, and culture all stacked together. Mangaline puts the idea neatly. Hunting is something you do to herbivores. When carnivores face each other, it just turns into a fight. That's basically the human story. We don't avoid predator meat because humans are too gentle for it. We avoid it because once better options exist, predator meat stops making sense. Modern abundance lets us choose the safer, fattier, cheaper animal lower on the chain. The top predator learns something very practical. If you can eat the cow, don't spend a fortune raising the lion. And if a charming social predator ever convinces a whole club to protect her, well, same lesson. Carnivores are expensive to chase, dangerous to trust, and very good at getting fed. Thanks for watching. Subscribe and check out the videos on screen for more strange little lessons from nature and human history.